All right. This one's a good one. The interior angles of any quadrilateral, like a square, a rectangle, a rhombus, any four-sided figure add up to 360 degrees. That could come in handy because a lot of people forget that. Parallelograms and all quadrilaterals add up to 360. The sum of the interior angles of any figure can be found using the formula below. I don't see this one very much on the SAT, honestly. So if you have like an 8-sided figure and you want to find the sides of the interior angles, you put the 8 where that n is. So it'd be 8 minus 2, which would be 6. 6 times 180 tells you the degrees of the interior angles of any figure. So if you have a 12-sided figure and you want to find the sum, you just put the 12 in there. Now, I do see these ones, vertical angles. If you had a decent geometry course, this should be really easy geometry. It's not super hard geometry, but they make it tricky. Vertical angles are congruent or equal. So angles B and C below are vertical angles. So we have angle B and C, these are vertical angles, and so you know vertical angles are always going to be congruent. And then we know that A and D, they're vertical angles and they're congruent. You also know that A and E are corresponding angles. Remember all this? Do you guys remember this from back in the day? All right,
Yeah.
so a little bit. So you're gonna need that for some problems that we do today. Clear that out. Okay, back up to the top here. Here's some tricky stuff. Circles. So a fraction or a sector of a circle contains the same fraction of the degrees, radians, circumference, and area. Whenever a question discusses a fraction of a circle, you put the part over the whole. We'll just get to that when we do the problems. If a line is tangent to the radius of a circle, it makes a right angle. See the right angle right there? Isosceles triangles have 2 congruent angles, and the angles opposite the congruent sides are congruent. Equilateral triangles, all the angles are 60. The largest side of a triangle will be opposite the largest angles. Triangles have the same measure, same angle measures are similar, and the sides will be in proportion. Oh, I've never seen this one in my life. The area of a hexagon with sides length x equals 3 root 3 over 2 times x squared. I don't know. I've never seen that on the SAT or anywhere else in my entire life. So I wouldn't worry about that one. And then here's the trig, Judah, that we were talking about. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent opposite over adjacent. And they have this little way to remember it. It's SOHCAHTOA. So right here, SOHCAHTOA, SOHCAHTOA, which means sine, S-O-H, that's your so, ka is C-A-H, and tangent is T-O-A, opposite over adjacent. So we'll do some problems with that. One thing that you need to keep in mind is this one right here. I've seen this on so many tests, and it just seems super complicated, but it's really easy. So the sine of an angle is the same thing as the cosine of the other angle. And we're going to do some problems with that, so don't fret. We will get right to that. So as I said, we're just going to do the problems just to speed things up a little bit. I'm just going to do the problems. You guys think about them. I mean, it's fun to try them, but there's only 3 of you, so, you know, it's a lot of pressure for you guys. So a quarter of a circle contains a quarter of the degrees, a quarter of the area, and a quarter of the circumference. Use ratio to compare these attributes no matter what the fraction. Okay, so I've seen these on the SAT, so focus here. Let's get these problems done. There's probably too many today, but we'll see what we can do. So here we go. So point O is the center of the circle above. If the area of the entire circle is 64 pi, what's the area of the shaded region? So we want to find the area of that shaded region. So first of all, we need to find the area of the entire circle. Judy, looks like you're sweating it out here. It says the area of the entire circle is 64 pi. That's the area of the entire circle. So we write 64 pi. And then it's like a fraction is colored in. If a fourth of the circle was colored in, we would say times 1/4. But it's not that simple. It's 67.5 degrees out of 360 degrees. So you're taking the area times the fraction, this is the fraction shaded. So it's part over whole. These are tough. Today's going to be hard. Just brace yourself. We did all the easy stuff that wasn't really easy. So if you want to find just the part that's shaded, it's a fraction of the circle. So you're taking the entire area times the fraction of the circle. And when this is going to be, this is all going to, I just put all this in your calculator. It's probably a calculator section problem. And it's going to end up being 12 pi. You're going to take 64 times 67.5 divided by 360, and you're going to get 12 pi. So the answer is B. Do you guys want to ask any questions about that?
I had a question. Could you also do it as like a ratio?
What kind of ratio would you use?
Like I did it and I got the same answer, but I don't know if
Okay.
it would always work. I did 67.5 over 360 is equal to x over 64 pi.
That looks like it would work. Yeah. Never tried it that way. But another way to look at this is say this part was shaded right here. Do you guys see how this is 1/4 of the circle? So if the entire area is 64 pi, you would have to do the white one, it would be 64 pi times 1/4 because that's the fraction that's shaded. Or it would be, I guess we could say it like this, 90 over 360. That's the part that's shaded and it reduces to 1/4. So it's the whole area times the fraction that's colored in. And so in this case, it's 1/4. It's easy to see. But if you can't see it, you do the degrees over 360. All right. Moving onward. Let's see. Okay, they give this reference chart again. We don't need to worry about that. We know where that's at. Okay, here it gets even more complicated. I think there's only 2 examples of these parts over whole. So look at that guy. It says in the figure above, point O is, wait, the chat's going on. Oh, what page? Oh, hi, Chad. How come you're not showing up? Your camera, you don't have a camera? I don't see you at all here. We are on page 111. All right, good to know you're here, Chad. So look how complicated this one is. In the figure above, point O is the center of the circle, and segments JL and KL are tangent to the circle at points J and K respectively. If the radius of the circle is 10, what is the length of arc JK shown in bold? Usually if it's a major arc, they give you 3 letters, but they're not doing that. They're just bolding it out. So we want to find, bear with me because this is a little tricky. We want to find the area, we want to find the length of this. It says, what is the length? So it's this one right here. That length. Okay, we want to find that one. So what do we know? Like this would probably be towards the end of a section because it's more difficult. What we know here is if it's tangent, if a extended line is tangent to a circle at the radius, we know this is going to be a right angle. We're going to apply a bunch of different things in this problem. So we know these are going to be right angles. We have 36 degrees, and this is a quadrilateral. See how it has 4 sides? And remember, we talked about how many degrees are in a quadrilateral. Anyone want to say? I can't really see the chat. Not enough room on a screen for this. So someone might have said in the chat, but it's 360 degrees. So I know that there's 360 degrees, so I can figure out this angle right here. I'm going to take 360 and subtract 90 and 90 and 360, and I'm going to end up with 144 degrees. So this is 144 degrees. So a couple things here. We have if a line is tangent to the radius, it's a right angle. We have there's 360 degrees in a quadrilateral, which is a four-sided figure. We have 90, 90, and 36. We subtract those from 360, and we get this central angle is 144. So now we can do the same thing that we did. Well, this problem's just taken a level way higher. So we want to find the length of the bold. That's why there's only two problems here. We want to find the length of this bold arc. So instead of talking area, we need the circumference. So we're going to find the circumference of the entire circle. Do they give us the length of the radius? Yeah, it's 10. So we're going to find the circumference of the whole circle, and you need that formula. Circumference equals 2 pi r. We fill it in, so it's going to be 2 times 20, or it's 10. 2 times 10 pi. So radius is 10. And so the circumference equals 20 pi r. Take that r away because we have the r is 10. Okay, so the circumference is 20 pi. And then we're going to take it times the fractional part, which is over here, it's going to be 216 degrees. So if this is 144, this is going to be 216. So you're going to do the same thing. You're going to do 216 over the total of 360 degrees, and you're going to end up with 12 pi again. When you put it in your calculator, you're going to get 12 pi. Anyone have any comments on maybe another way you did it, or I know you didn't have time to do it. So it's the same thing. This time circumference you're going to use, instead of area, you're using the circumference formula. It's 20 pi for the entire circumference, but we only want a fraction of it. This is 216 degrees, which was kind of hard fought to get that out of a total of 360 degrees, and it ends up being 12 pi. Not my favorite problems in the world, but they can be doable. So you'll have some problems really similar to that to try for your homework. Okay, angles, next. Angles are way more fun. So here we go. Let's get to angles. These are your exercises you can do. There's not a lot of them. Okay, and there's all the reference stuff again. Now, the main thing you have to know with angles is everything adds up to, in a triangle, adds up to 306, or adds up to 180 degrees. Just think 180 for everything. 180 is your lucky number for this. So we have to figure out the value of x. So you can try it yourself, or you can just wait for me to do it here. There's a couple different ways to do this. The one way is you could just figure out 114. Let's see, I lost the place where I write. Hold on a second. Oh, Bryn's here. Oh, and David's here. When did you guys all come in? I'm just noticing that you're all here. We're doing class a little bit differently today. Instead of you guys working the problems, I'm doing them all because I want to spend more time on the real SAT that we're going to be doing. Okay, there we go. I still can't see everyone. Okay, whatever. All right, so for this one of the ways you can do this problem is you can figure out if two angles are on a straight line, they're linear pair, and so they add up to 180. 180 is your number. So this one's 66 degrees, and then you know that all three of these angles in a triangle have to add up to 180. So this isn't how I did it, by the way. So that ends up being, I lost my calculator because I didn't do it this way. So 180 minus 82 minus 66 is 32. So this is 32. I'm just doing it like the easiest way if you don't know a certain thing. So I found out all the degrees of this triangle, and then this also forms a linear pair. So this is going to be 148 degrees out here. So the answer is 148 degrees. Another way you can do it is the angle outside has to add up to the two remote interior angles. So if you add these two up, you're also going to get 148. Okay, Chad, why'd you say 98? Did I write something wrong? Just wondering. But the answer is 148. All right, any comments on that one? Okay, such silence we get on Zoom. Okay, that was the easy problem. Let us move to the more difficult one. Whoops, sorry. Zoom issues. So let's talk about isosceles triangles. Again, well, let's talk about these parallel lines. I missed this. So it's easy to get stuck on angle questions if you don't know the rules, but knowing them might not be enough if you don't know how to apply them. These two rules can be difficult to see. Okay, we went over this in the beginning. Parallel lines, you know that A is equal to D is equal to E equal to H. The vertical angles are equal and the corresponding angles are equal. So know that. And this is a big one, isosceles triangles, the angles opposite congruent sides are congruent. So check this one out. This one is taking us a little bit further. You can just write, make sure when you take the SAT, you can write right in your book. So you just want to mark it up as much as you can. So the first thing I'm going to do is I'm just going to go and mark it up. So let's do that. We have, it says in the figure, AB and CD are parallel. So these are parallel, AB, CD. AE, and if you don't want to listen to me, you can just do it yourself. AE and AD is equal to AE. So these are equal. If the measure of ABC is 95, what is the measure of angle ADE? There we go. So lots of different ways to go about this. We know that these two lines are parallel, right? And inside of parallel lines, the angles add up to 180 degrees. Hopefully all your geometry is still in check. So this angle and this angle, because they're in between parallel lines, are going to add up to 180 degrees. So this one's going to be 85. Got that, right? You guys tracking with that? What else do we know? Is anything else parallel? Yeah, we have these parallel. These are parallel. That helps. And so we know that this one and this one have to add up to 180 degrees. So we know that this is 95 and this is going to be 85. And the thing we learned earlier is these should all add up to 360 degrees because it's quadrilateral. Now, where we go from here, if this is 95, we're just working that 180. We're working it as much as we can. So we have the 95. So this one's going to be 85 because these two have to add up to 180. And because these two sides are the same, then the angles opposite them are the same. And if this one's 85, then this one has to be 85. So it is 85 degrees. So anyone have any questions on this one? It's kind of fun. It's like where you just start filling things in and working your way to the end. Those are some of the easier ones on the SAT. Speak now or forever hold your peace. Okay, just moving right through today. Okay, here we go. So these are the problems you're going to do. Really do these ones because I'm doing these especially, so you're not getting a lot of practice in doing these problems, but these are the same things. You just want to, like this one, these all have to add up to 180 degrees, right? So you would add these up, set it equal to 180. So many is 180, 180, 180. All right, similar triangles. These are fun too. Similar triangles have the same angle measures, which means the side lengths are in proportion. In school, similar triangles involve tons of rules and long geometric proofs. But fortunately, Chad, you never took geometry? Really? I thought you were in my geometry class. All right, that's a little challenge there. All right, on the SAT, you can skip the proof and go straight to the ratio, which everyone's happy about. Just make sure you know what the question wants. So if you have two similar triangles, all the sides make proportions. So let's do it with this one to show you what we do. Now, how do we know if this one is, these two are similar triangles? Now, similar triangles, all the angles in both triangles are the same, the sides are just in proportion. So let's see if we can figure that out. So we have, in the figure, AB is parallel to CD. So we have this one is parallel to this one, and they intersect at E. What is the length of AC? Yikes. Sometimes these like kind of make me panic when I hit these on the SAT. I don't know why. So these are, in fact, similar triangles. If you're not sure, just assume they are, because they're not going to have problems like these if they're not similar. The way we know they're similar is we know the vertical angles are congruent. These are parallel, so these angles like this, the opposite sides of the transversals are going to be the same. So these are similar triangles. Pretty much you can just assume on the SAT, if you have a problem like this, they're going to be similar. So if they're similar triangles, we can make a proportion with the sides. Now, really important, there's the 3, 4, 5 triangle. That is numbers you have to remember. If one, now these aren't right triangles, forget it, take that back. That is important, but not for this problem. Okay, so because they're similar triangles, their sides are going to be proportional. So you kind of have to take this E and like pivot the second triangle on top of the first, and you can see that B and D are going to line up, and C and A are going to line up, and then E is going to line up. So you can just make a really simple proportion. You're going to say 10 over 15, so this one over this one equals, we need this number right there, equals X over 12 over X. It should be 12 over X. 12 over X. So make sure you go, I'm going left to right, left to right. Make sure you don't do what I just did, X over 12. So I did 10 over 15 is equal to 12 over X. So that this is what a proportion is. If it's similar triangles, you make a proportion, you cross multiply, you get X equals 18. Now, don't make this mistake. Look at this. Do you see how 18 is over there? It's like tempting you. It's saying, pick me, pick me. It's like the devil, you know? This is like they have put devil answers over there. Look at the problem. What's the length of AC? So here's A, here's C. This is 18. So this is going, the final answer is going to be 30. All righty. Judah, you're looking like something happened. What happened? Anything?
I have no idea.
You have no idea what I did?
I'm so lost.
Oh, you poor boy. Okay.
Yeah, I'm confused too.
Who? Chad? All right. Two.
Yeah.
Okay. There's two of you. I will do the problem. Okay. Now, the two that, did you have Judah? Did you have geometry?
Yeah, you lost me at the, like, you got the fractions and then you lost me after that.
Oh, did you understand this part right here?
Not really.
Okay. So if I take, okay, let's make one triangle down here blue, like this blue triangle, okay? A blue triangle, and then we'll call this one the red triangle. All right, the red triangle. These are similar triangles. So if I flip the blue triangle so that it's the same direction as the red triangle, and you know, everyone knows I'm a horrible drawer, so just bear with me. Okay, so I flipped this triangle here. I flipped it, I'm bringing the D up where the B is. So I'm gonna put the D there, and let's see, the D went there, the C is there, and the E is here. All right, so now block this one at the sides. Let's see, EC is 12, CD is 10, and we don't know this side. Okay, so forget this one's here. Okay, bye-bye that one. Now we just have this triangle and this triangle. So now, once we, do you see how I flipped that, Judah? Chad? I flipped it, yeah, so that the angles match up, because C had 3 lines going through it and A had 3 slashes going through it. So I rotated on this. Now we do this over this equals this over this. I did it upside down though. I did 10 over 15 equals 12 over x. So I made a proportion, sides are proportional. And then where you said I lost you, you cross multiply. You multiply across like that and you get 10x. And you go across like this, which I just did it without using my calculator or something. You get 180. And then you divide both sides by 10 and you get x equals 18. So that's my attempt to explain it again. All right, we have
I thought you said that A was wrong. That's why I was confused.
Oh, it is wrong. It is wrong because see this part right here is 18. But what's the question asking for? It's asking for AC, which is this. So you have
So
to
you
add the
add?
12 onto the 18. to get
Oh.
30. Yeah,
Okay, that makes sense.
I know, it's complicated. The SAT is complicated. All right, I'm going to erase all that. That was a big mess. Okay, there is one more of these. There's not as many problems this time, I don't think, but let's see. Okay, so another similar triangle problem. So maybe this one will click. The twist, they will try to disguise similar triangle questions, but don't be fooled. If a question involves triangles with non-specific angles, there's a good chance the triangles are similar. So you can pretty much assume all the triangles are similar. But let's look at this. Figures not drawn to scale. So what? So we are going to, we know that this one is parallel to this one. We know that AC, whoops, I can't see the C, it must be up at the top. Okay, AC, this one was a little bit tricky, is 40. And the ratio of BD to AE is 2 to 5. Yikes. What is the length of AB? Now, these triangles are similar because they both share the top angle. Since these are parallel, this one's going to be the same as this one, and this one is going to be the same as this one. So these two, the little triangle on the top and the whole big triangle, they're similar. So we know the sides make two fractions that are equal. That's called a proportion. So how do we set up the proportion? How did I do this? I'll have to look. Okay, so we're going to do the ratio. So here's 2, the bottom to the bottom. So it's 2 to 5 equals, so that's the little one to the big one. We don't know this one, so I'm going to call it X. We don't know that little side, but we know the big side. So equals X over the big side, which was 40. So it's a proportion. The bottom over the bottom equals this side of the little one over this side of the big one. So here's the proportion that we made because they're similar triangles. You cross multiply, so I'm going to go this way. So you get 80 equals 5x. Divide both sides by 5 and you get x equals 16. Again, look over here. Do you see that? They have 16 as the answer. But that's not the answer because they want to know what this isn't the right x. We solved for this x. This equals 16. This side is going to be 40 minus 16, which is going to be 24. You can save yourself tons of mistakes by making sure you go back and answer what they're asking for every single time. I took test one we're going to do today, test 3, section 3, and I was just rushing through it, and I did the problems right, but I didn't answer the questions right. So they're going to get you on that. What is the length of AB? And so you have to add 16 and you have to subtract the 16 from the 40 and you're going to get 24. All right, that's your similar triangles. If you just like, that's not my thing, then when you hit those, you might want to skip them. But there are problems on the next page that you can practice and all the answers are in the back of your book, really clearly written out. So that's good news. Okay, you guys aren't commenting much. Okay, so here's all the problems that you're going to practice. There's not a lot. Cylinders. Cylinders are really fun. So the formula for cylinders, let's look at that. It is right there, shaded up for you. The formula is volume equals pi r squared h. Know that when you're going in there. I've seen like cylinder problems on like every single SAT test. So this is a cylinder. Basically what you're doing is it's the area of the circle, because that's pi r squared, times the height. So let's see if we can do these. Some are super easy. Some are like just they give you everything and you just have to put it into the formula. These are not quite so easy, I don't think. So let's get the formula out. Pull it out here. So the formula for a cylinder is volume equals pi r squared. That's a circle. That's the area of the circle, because you have to take the area of the circle times the height. So get that out. Know it. Don't have to look at it on the day of the test. So companies designing packaging for a food product. The packaging is in the shape of a right circular cylinder as shown above. The height of the packaging is 9 centimeters and the volume must be exactly 144 pi cubic centimeters. What is the diameter of the packaging in centimeters? Okay, so they gave you two pieces of our formula. They gave us the height and they gave us the volume. So we can put those two pieces into the formula. Feel free to interact and ask questions and, you know, be unzoomy. So I'm going to put in the volume. It told us that the volume is 144 pi. So I put that where the V is. V, volume, equals pi. We don't know the radius, so I'm going to leave it r squared, but we know that the height is 9. So this one is on the simpler side. You just plug in what you know. V is 144. We don't know pi. We only know pi. We don't know the radius, and we know the height is 9. So I put it in there. Now I need to get the radius. So the pi's just cross out. Anything on the same side can be crossed out like that. So pi is gone. If I divide 144 by 9, we get 16 equals r squared. And the square root of 16 is 4. Again, look at the question. The diameter, we just found the radius. It's 4, so make sure you put down for an answer 8. Everyone should be able to get these right. It's just plug them in the formula. All right, Chad, are you good with that? Just checking to make sure.
Yeah.
That one's good? Awesome. Yeah. Okay. Chad, when are you taking the test?
September, October, in the spring and fall.
Wait, you're not taking them all those times, are you?
Yeah, I'm gonna take it as many times as I can.
All right, make sure like you don't just go, if you go from one test to another without practicing in between, your scores don't really go up. You have to.
Yeah, for sure.
So go back through everything.
Yeah.
Okay. Here's where it takes the evil twist. Let me just make sure. 2 cylinders. I'm a big proponent for myself anyway. Maybe you're not all like me, but I like to draw everything when I get to SAT. I just start drawing. As soon as I see it's a cylinder, I start drawing. So this one says a grain silo in the shape of a right circular cylinder has a volume of 256 cubic yards. What is the volume of a second grain silo that is 3 times as tall and 1/2 as wide? So let's draw our cylinder. So here we go. This is one of our cylinders. There we go. And then we need one. We know the volume of this one is 256. So draw. And then we have a second one. It's 3 times as tall and 1/2 as wide. There we go. All right. I don't know if I did that right, but just pretend. It looks more like a vase than a cylinder. Okay. We don't know the volume of this one, B. Hope everyone's playing along at home. So, oh my, so they want to know the volume of this one. Oh my goodness, how are we possibly going to figure that out? This seems impossible. So we pull out our formula, volume equals pi r squared h. For this one, we know the volume is 256. We don't know either of their radiuses. So this is for the first one. So the first one, this is 1, this is 2. So the first one is volume, whoops, we know the volume, is 256 equals pi r squared h. These kind of can get you, but just watch what I do, especially for you guys that this seems easy for you. Just watch what happens here. So the second one, it tells us that the volume, this is 3 times its height. So this one's 3h, right? It's 3 times as tall. This is h, and this one's r. And the radius is, okay, so it's 1/2 as wide. So the radius, it's going to be 1/2 of the radius. So that should be common sense to everyone, right? It's 3 times the height and 1/2 the radius. It does say it's 1/2, right? Was the volume 3 and 1/2? Okay. So now I'm going to go to equation 2, and I'm going to do volume equals pi, r is 1/2 squared times 3h. This is hard, but I think when you see this, it'll help, help you later to know what to do. So I don't know either radius or height of either of these. I'm only going to do a little comparison. So I'm going to simplify this out. I'm going to get 1/4. So it's going to be 1/4 times 3h, and then I'll throw the pi at the end, and we're going to get the volume equals 3/4 pi. I lost my r. I lost that r. Don't lose that r. Okay, r squared, and that should have been a 4. 3/4 pi r squared. Call me out when I mess up. Okay, so h. I forgot the h. There's the h too. Okay, so now we're going to compare 1 and 2. Here's 1. 2, I just substituted those values in. And you see that the volume of the second one is 3/4 the volume of the first one. It's a little tricky. So this is the same. These are perfectly the same except this 3/4. So now we know that this one is 3/4 as big. So I'm going to take 256 times 3/4, and we get 192. So anyone want to ask any questions on that one? So I just took in the formula, even though I messed it up. You put your 1/2 r for the radius squared, and then you have, you just bring everything down and put it all together, and that's what you get. David, do you think that one's tough? Yeah, so everyone soak that in. Yeah, that's no fun. I would not call this one fun. But you plug it into the formula. You plug these into this formula, and then you compare the original with the new plugins, and you can see it's 3/4 difference. So hopefully that helps. There's probably other ones you guys can try. Okay, moving on to everyone's favorite topic, trigonometry. There's not very many of these on there. Like, there's only 5 of all these kind of problems on the SAT. But hey, it's 50 points. 50 points are 50 points. So here's all your cylinder things. Yeah, that one looks kind of tricky, but it's not. That pill one, it's not bad at all. All right, trigonometry. So Judah, we'll see what you can do. If you didn't have it, you didn't have it. So here we go. The trigonometry problems are actually going to be your easiest ones if you understand trig, because they make them fairly easy. So let's do this one together. Given the right triangle ABC above, which of the following is equal to A over C? Oh my goodness. Like, it sounds like they're talking Chinese right now. But let's just break this down. If we did the sine of B, we'll do each one of them and see which one ends up being A over B. So let's do the sine of B. What does that mean? Here's B, right? The sine of B, this is for you, Judah, is opposite over hypotenuse. All right, so we're going to go opposite. So opposite is going to go up here. That's the opposite. So it's going to be B. And the hypotenuse is what's opposite the right angle, which is C. And look, is that A over C? No, that's not A over C. You are out. That one is not the right answer. All right, so let's go to the next one. Let's do the cosine of B. So cosine of B equals adjacent This is the COA over hypotenuse. So here's B, adjacent. So it's going to be A over hypotenuse, which is opposite the right angle, over C. And look, ding, 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 ding. We hit it. So this is the correct answer. Now they put these towards the end because they think people don't know trig, so a lot of people miss this. But that's what this one's talking. Which is the following is equal to A over C. So how are you feeling about that one, guys? What are your feelings? No comment? Okay. All right, so fun. Okay, yeah, it's a little, they make things look more complicated than they are. So like, you know, that does sound crazy right there. All right. So let's go to some other ones. Here's one, the twist. They'll complicate the triangles or give you side lengths that don't match with the trig functions. Just remember, these are ratios. Scares me a little bit. Okay, what do we do with this one? So it says, in the figure above, sine of B equals 3 over 5. So what is sine? Well, let's talk about what sine is again. Sine is opposite over hypotenuse. So the sine is 3 over 5. So here we go. Here's B, right? The sine is opposite, which would be 3, over hypotenuse, which is going to be 5. This one is tricky. Okay. Now, this is that 3, 4, 5 thing that I said you really got to memorize. It's a special right triangle. If you have a hypotenuse of 5, and one of the side lengths is 3, the other one has to be 4. And it's also going to work for multiples. Like if you had 10, 9, this one would be 8. Multiples of these numbers. So you could have 6, 8, and 10. Any multiples of it would work. Okay, so now what do we want to do? Now it tells us that AC is actually 12. The actual length is 12. So what do we do with that? Now, sine, cosine, tangents are ratios. So we are going to do our good old-fashioned ratio. So what is the length of BC? Well, we don't know what this length is. We know the ratio is 3 to 4. So you define this, by the way. It didn't come with a problem. So we're going to do a ratio. So we can say 3 over 4. 3 over 4 equals 12 over what? And if we cross multiply, we get 3x equals 48 and x equals 16. So that one had like ratios and trig built in. But first of all, you want to set up your triangle. This is just a ratio. And then this isn't 12 is an actual length. And so we want to use the ratios to find the other actual length. All right, good luck with those. Let's see, how do you guys feel about that? Yeah, hard at first. Okay, all right, thanks for commenting. All right, so here's one that's gonna trick you all, but yeah, I thought you would like those, David. You had like all kinds of math under your belt. Okay, now look at these two. This is like, I'm gonna do actual problems because they don't have any examples for this one. So the SAT doesn't give any trigonometric formulas beside the fact that 2 pi radians equals 360 degrees, and you need to know SOHCAHTOA and this one. So let's just do a problem. They don't give you any, but I thought we would do one on the next page. So let's move down here. So I'll try to, well, let me just try to, yeah, let's just do the problem. So the problem is, to turn the page, we're going to do number 3. So here we go. One angle of a right triangle. So I'm going to draw a right triangle. One angle of a right triangle. There we go. Measures 8 degrees. I'll just put that down here, I guess. And where cosine of A is 3 over 5. Stick with me, guys. This isn't as hard as it seems. Okay, so 3 over 5. So cosine is adjacent over hypotenuse. Okay, you guys got that? So all I did was I set up my triangle using what they gave us. Cosine is of A degrees is 3/5. So cosine is adjacent over hypotenuse. Again, look at this, the 3, 4, 5. You're going to see that all over the place. So I'm going to put my 4 here. Now, they want to find what's the value of the sine of 90 minus A. So everyone shut their cameras off. Okay, so what's the sine of 90 minus A? Well, where is 90 minus A? If this is 90 degrees, this one and this one have to add up to 90. So this one is 90 minus A. It's always the other angle. Now check this out. We want to know the sine of 90 minus A. So let's find the sine of it. It's opposite over hypotenuse. So it's going to be 3/5. So when they ask for the sine or cosine of 90 over A, okay, the sine of 90 minus A, that's just going to be this angle. And if you remember this formula, hold on, let's go back to this formula. Just keep in mind the answer is 3/5. If we go back to that other page, here we go. See this other page? The sine of x is the same as the cosine of 90 minus x, and the cosine of x. So you don't need to know. Judah's not here anymore. Chad, how about you? I don't know. The sine of x is the same as cosine of 90 minus x, and the cosine is the same as sine minus x. So when you see this, and they say the cosine of A is 3/5, what's the sine of it? Well, that little rule says if the cosine of an angle is 3/5, the sine of the other angle is also going to be 3/5. So you don't have to draw anything for this one. You would just say, oh, I remember that. It's 3/5. These are the same. You just have to memorize that. They're on like every test. I don't know if you guys have noticed that. It's like, what is this 90 minus A thing? It's just the other angle, which ends up being the same as the sine of the first angle. So I don't think there's any, oh, I wanted to show you this one. Let's jump over here to this. This one is in a right triangle ABC above, cosine of B equals 0.8. And you're like, what is 0.8? So this is what you do on this problem. Cosine of B is 0.8, which is the same as 8/10. Okay, see that? Cosine of B equals 8/10. So if they have this decimal, make it into a fraction. So cosine is adjacent, which would be A, over hypotenuse, which would be 10. And this is a 3, 4, 5 triangle, but it's just a multiple of 2. So it's going to be 6, 8, 10. So that means this side has to be 6. You guys tracking that? So I used this to fill in my sides, and then when it says tangent of A, so I go to A, here's A, tangent is opposite over adjacent, so it's going to be opposite over adjacent, so it's going to be 8/6 or 4/3. Any questions on that, like where I got the numbers, where I got the 6, 8, and 10?
Yeah.
Chad, is that you?
Yeah.
Okay, so do you remember that cosine of an angle is opposite over adjacent a hypotenuse? No, it isn't. I made that up. It's adjacent over hypotenuse, right?
Yeah.
Okay, so this one, this red's kind of bright, but over here, cosine of B is 8/10 because this is 8/10. It turned into 8/10. See that?
Yeah.
So I'm going to go to B right here, and I'm going to put the 8 where the adjacent is. It's right here. And the 10 where the hypotenuse is right here. And that's where I got those numbers.
Okay. Thank you.
And then you have to get this one, Pythagorean theorem, or you just know it's a Pythagorean triple. Yeah, a lot to this stuff. Okay, are we on the last thing? We are on the last thing before you guys do the test. And then we're going to talk about the test. Rachel wanted me to go over one of the problems from last week, so we'll do that then too. So the last part of this whole book is called Advanced Geometry. Just what you wanted, right?
Yeah,
geometry.
completely.
Hey, we didn't get any advanced geometry yet. So this one is using these 30, 60, 90 triangles. Now we did this in Algebra 2, we did this in geometry, so there shouldn't be any excuse, guys. But we don't use it very much, so it kind of goes away. Here we go. Let's see. We have this triangle. What is the value of BD? So, oh my, a little tough. So this is 30, 60, 90 triangles. What you have to know with your 30, 60, 90 triangles, let's just do the ratio out here. Let me just do one. Oops, that didn't work out quite nicely. Let me do that again. So I can only draw 45, 45, 90 triangles, guys. I'm so sorry. All right, let me try one more time. All right, just go with that. Okay, so we have 30 and 60, 90. All right, so the ratio would be, if this is 2, I'm just trying to figure this out. How did we do this before? Let me look at that formula. The formula is, okay, this one's gonna be x, this is gonna be 2x, and this is gonna be x root 3. All right, so that's how it works. So if you know the side opposite the 30, the hypotenuse is gonna be twice that. If you know the hypotenuse, the one opposite the 30 is gonna be half of that. So the one, we have the hypotenuse, which is 8, the one opposite this is gonna be 4. So we got that, right? And then this side is going to be whatever this is times the square root of 3. So it's going to be 4 square root of 3. And I think that's all they wanted you to do there. So that's the answer. See how that works? You have to know this little formula. The one opposite the 30 is half of the hypotenuse. Once you find the one opposite the 30, the one opposite the 60 is 4 times the one opposite the 30. So hopefully you learned that in class. There's a lot to learn if you didn't learn this like in your regular classes. All right, one more crazy problem. It's like a crazy thing. Okay, so you guys can see it in your books. And if you wanted to work ahead, you can always do that. Okay, look at that one. Oh my goodness. Can we do this? I'm not sure. So the large square above has side length 2. Which of the following represents the area of the small shaded square? Oh boy. So what we're going to do here is you have to think outside of the box. And you might want to do these, you know, spend some time on the problems that come with this, because they're definitely, if you're trying to get a perfect score, you want to be working all these problems. So I know some of you are aiming for that 800. So what you're going to do on this one is you're going to find the area of the big square, and that's going to be 4. See? 2 times 2 is 4. That's a big square. And then we're going to find the area of each of these triangles, and we're going to subtract it from 4. And we can actually do this. I know it sounds crazy, but we can do it. First thing we know is this is going to be, since this is 90 degrees and this is 2 times what's left, the only option is for this to be 30 and for this to be 60. That's the only option if you're going to have 2 times the x and you're left with, you have your 90-degree angle there. So if this one is 2, then the side opposite the 30 is going to be 1. We don't care about that one actually. And the one, this long side right here, the height, is going to be 1 times the square root of 3. So this side's the square root of 3. So I took this, the hypotenuse, since it's opposite the 30, I divided by half. And then to get this long side, I took this times the square root of 3. We did that in the other problem. So there's 4 of these triangles that are all the same. So we're going to subtract off 4 triangles, the area of 4 triangles, which is going to be 1/2, the base, which is 1, right? 1, this is, actually we did need this side. This is the base, and this is the height. So it's 1/2, and it's going to be times 1 times the height, which is the square root of 3. Yikes. So if we do that, we're going to get 4 minus, this is going to be like this, 2 root 3, and that is this answer right here. So you have to think outside the box. It took me a while to figure this one out. I was doing all kinds of weird things. It's nice and clear for you guys because I just did it the right way right away. Anyone have questions on that 30, 60, 90 stuff? Questions, anyone? All right, we're quiet tonight. All right, that took the whole time without me letting you have time to work them, so sorry about that. Okay, so you want to go in your books right now and go to test 3. David, did you get test 3 out? Yay, nay?
What page is that on?
In your book, in your test book, it's page 1115.
Okay, thanks.
Yeah, and we're going to go over this, just we don't have as much time as I wanted to. Okay, you got it on the computer. Okay, so guys, I'm going to set the timer for 25 minutes. So get ready, get set, go. All right, that was the timer, everyone. So put your pencils down and let's go over the answers for whoever is left here. This time, what I think I want you to do is if you could, when we're done checking them, type in the numbers privately, the ones you missed. So I have some idea which ones were most missed. So hopefully you guys are out there. Everyone's really quiet. So here we go. You can look at the screen or you can just listen to me call them out. So the numbers are 1 is C, 2 D, 3 is D, 4 is B, 5 C, 6 C, 7 C, 8 A, 9 A, 10 A, 11 B, 12 A, 13 B, 14 A, 15 D, 16, the answers are 1 or 2, 17 is 2, 18 is 105, 19 is 370, and 20 is 3/5 or 0.6. So in the chat, just do the private one to me, type the numbers that you missed. Yeah, missed a ton. We'll type them in. We got to cover those. This is your last class. Okay. Don't be embarrassed. I'm the only one that can see. It's fine. SATs are hard. Okay, anyone else? Yeah, definitely study. Rachel, come on. Are you still here? Yeah, Rachel, Bryn, Chad, somebody. Are you guys even here? Okay, Bryn. Okay, good. Okay. Rachel, still put your numbers you missed. This wasn't a good test for you guys. What happened?
I haven't done math in like 3 months, so that's probably why.
Yeah, well, that's why I thought we would go over these kind of more in detail than normal. Just because it's good to review all the different types. Yeah, and each test, some tests are harder than others. No doubt about it. I did lose my pen though to write with on the board. Here it is. Okay, come on, Rachel. Waiting for you. Okay, so let's go over some of these. I wrote them down. I'm just going to do the people that wrote them down because, like, Chad, if you want to put the ones you missed, you can do that. But I'm going to start. Okay, any of the last 5? Okay. All right, so let's just start. Looks like the first one. All right, Chad, I get it. Okay, so it looks like the first one we have is number 7. So let's hit that. Really? You didn't miss any till 7? Okay. Actually, you know what? I have these. I actually copied these pages this time. All right, let's see what I got here on this. Okay, Chad, I get the point. All right, well, let's hit these from the first one that we missed was number 7. Where is that? Okay, why is that page there? I don't know. Okay, these are out of order apparently. Okay, so let's hit down here, number 7. Okay, 7 is tricky. It's something that you're not really comfortable with. It's not really taught very well anywhere. So they want to know, let me see if I can blow this up. Can I blow this up? Hold on. Yes, I know I can. There we go. Okay, we need it bigger to do this. Okay. This one says the function, whoops. Okay, hold on a second. This Zoom thing sometimes gets me. Okay, I'm gonna move that over there. Okay. So it says the function f is defined by a polynomial. Some of the values x and f of x are shown on the table above. It's hard. For which must be the factor of f of x? It's like really, you know, who knows what that means? That's really complicated. You're going to need to go back and study the part on functions. But you have a function, like if you had the function, if you drew the function on a graph, the factors are the places where the graph crosses the x-axis. So these would be the factors. I'm just made up a random one. It might not be the one on here. So the factors are where y equals 0. That's where the factors are. So you might have some aha moments here. So remember, when you're doing this, this is x, the f of x is the same as y. So where is y equal to 0? It's right here. So it would have crossed the x-axis at 4, right here, 4. So the factor is x minus 4. All right, you got that? Those are tricky, but anytime it says factor is the same as the 0 or the solution. You know, those are all the same thing. Okay, hopefully that helped. Okay, number 9 was the next one. So I'm just doing what people wrote down. If you didn't write them down, then I'm not doing them. Okay, number 9. One of these long ones. No, went the wrong way. Good. 9. It's backwards is what it is. Okay, there it is. Okay, these are a pain in the neck, but in the system of equations above, k is a constant and x and y are variables. For what value of k will the system have no solutions? Now think about it. When do you have no solutions? When you have lines. It's when they are parallel. So if we have parallel lines, there is no solution. How do you know if two lines are parallel? Well, the slopes have to be equal, right? The slopes have to be equal. So what I did when I did this one, I think there's other ways to do this one, is I solved each of these for y. So that means I put the kx on the right side and divided by -3. And I got, just to make a long story short, I got y equals k over 3x minus 4/3. So that's that one. Put that over there, divided by 3. The second one is we're going to get y equals, this one was 4/5 x minus 7/5. Okay, you see that? Now, if the slopes are the same, the lines are going to be parallel. And if they're parallel, there's going to be no solutions. So you're going to do, you want to set them equal and see what k has to be for it to be 4/5. So cross multiply, do all that fun stuff. 5k equals 12 and k equals 12/5. So the answer is A. You guys can comment and things and say, wow, that was cool. I never thought of that. Oh, that makes sense. You know, anything like that makes things a little bit more interesting. Okay, so just remember that if they have no solutions, the slopes have to be the same, set them equal. Yeah, good. Yeah, that's my goal, make things make sense. Okay, number 10. In the xy plane, the parabola with the equation y equals x minus 11 squares intersects the line of the equation y equals 25 at 2 points A and B. What is the length of AB? Okay, when you're first looking at this one seems really hard. I get it. Okay, so we have a parabola. I draw everything. So xy plane, look at our little parabola guy here. Okay, it's x minus 11 squared. So what does that mean? Did I do this one? Yes, I did. Oh, I did. Okay, this is complicated. All right, I'm going to have done it the complicated way. I'm sure there's an easier way. I tend not to do things easy ways. So what I did was it intersects with a line y equals 25. So I'm going to substitute 25 in for that y. 25 equals x minus 11 squared. We're going to do the mature way of foiling that and get x squared minus 22. Bryn will appreciate this, plus 121. And then I'm going to subtract the 25 and get x squared minus 22x plus 96. And I'm going to factor Hard to believe. This one seems like it should be like harder, farther along. And we're going to get 6 and 16 if I factor them like that. And remember, the factors tell you where it's going to cross the y-axis because it's going to give your solutions. You're going to get x minus 6 and x equals 6, x equals 16. So if I put those two on, 6 and 16, this is 6 and this is 16, the distance between those is going to be 10. That's where it's going to cross your parabola. So they want to know what is the length of A, B, and it's going to be 10. From 6 to 16 is 10. Ah, that one's tough. Yeah. All right, was that wow for this one, Chad? I'm pretty impressed by that one. That was tricky. Okay, next. That's why I thought it's important to go over these. Number 11. We just like covering them all today. 11. Keep an eye on the time. I'm not going to go over. Okay. Oh, 11. Okay, how do we play with 11? So I mark everything up. So let's see what we can mark up. It says in the figure they intersect x plus y equals u plus w. Important thing here. So we know that x and plus y, this one is equal to u, don't mess this up, x and y, u plus w. Okay, these are the same. All right, so I'm going out there, going on a limb. Now I'm going to start marking up everybody else who is the same. So vertical angles, whoops, that didn't curve very good. So this one is the same as this one. I'm going to make a big mess here. This one is the same as this one. And this one, 1, 2, 3, 4, is the same as this one. So all I did was marked my drawing up. And now I'm going to go and go down to these qualifications and see which ones are true. So is x equal to z? Well, I'm going to look. Why do I have, this should be 4 slashes through here. So x and z, they don't look alike, but let's look at something here. I think this is the tricky part. So a 2 and a 3, let's see, how do I do this? This is a 2 and a 3, and this is a 2 and a 4, right? There's 2 and a 4 and a 2 and a 3. That means the 3 and the 4s have to be the same. Hopefully that makes sense to you. So since these are the same, and these are both 2s, that means these both, and this is a 4 and this is a 4, that means this one has to be a 4 because 2 and a 4 and a 2 and a 4. So now we can see who's the same. Is x the same as z? So x is a 4, z is a 3. No. Actually, it's true. Let's see what I do wrong. X equals z. I don't know what I did here. 3, 1, 1 and a 3, 1 and a 3. Okay. So it should be x equals z. I don't know. I'm not seeing it. Something I did wrong. Oh, okay. Because w is a 4, z has to be a 4. Because see how they're vertical angles now? So I had to add another one to z. So yeah, x and z. Is y equal to w? Well, y is a 2 and w is a 4. So no. Is z equal to t? Well, this is a 4 and this is a 4. So yes. So it's 1 and 3. Yikes. That was a little tricky. Yeah. Okay, good. All right, now let's see. Next, we have number 12. Somebody missed a lot in a row here. Not saying who. Okay. Oh, this one was hard. This was a really tough test, guys. I think it was. So in the quadratic equation above, A is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? Okay, so D is the y-coordinate of the vertex. This is what I did. Okay, I did my drawing because I draw everything. I drew it out like this, and we have a parabola. Now, if you look at this, let's see if I can move my little bar. Okay, remember how we talked about how you find, how you can find the places where it intersects the x-axis or the solutions? It's going to cross through here at 2. That's a solution, and -4 The factors give the solutions right there, -4. And then what I did was I just danced between these. So I went here to here, crossed that out. I found the middle, and then here to here. And so the middle is at -1. So your x coordinate, your vertex is CD, so your x coordinate is -1, and then we just need to find out what D is. And the way you do that is we're going to put in the -1 up here where the x's are. So we're going to get A, so it's going to be -1 minus 2 is -3, and -1 plus 4 is -3, and so on. So one of these should have been a +3. That one's a +3. And then we're going to get -9A. I think that one was pretty hard. I give you that one. That was tough. All right, so just remember, like a lot of things you want to go back and look at, how you can look at something and say, okay, it's going to cross at 2 and -4. Those are the x-intercepts. So you got to know all that. That comes up a lot. Okay, nobody really put down 13, so let me look at it. We might just skip that one. It's going this way, 13. What? You guys didn't have trouble with 13? I was really excited about doing that one.
Can you do it?
Can I do? Oh, sure. You really want me to. Okay. Number 13 now. These look really mean, but this is really about your algebra. Okay. Oh, David, I didn't see 13 written down on your list. Okay. So this is all about your algebra. Now, if you notice that the denominator of this one is ax minus 2, and this one, you could write it with a denominator of ax minus 2. So that's what I'm going to do. I'm going to take the right side, and I'm going to make it have a denominator of ax minus 2, and then I can set the numerators equal to each other. So I'm not even going to write down this big mess because I don't really have room. So I'm going to write the denominator of the right-hand side, ax minus 2. It's tricky. That's why I was surprised no one put it down. And I'm going to multiply. So this one doesn't have an ax minus 2, right? So I need to multiply this whole thing times ax minus 2. And oh no, we have to FOIL because it is a binomial times a binomial. So I'm going to FOIL that. And let me just look at what I got. So we're going to get, if we do the first, it's negative 8ax squared. If we do the outer, it's going to be negative 3ax. Inner is going to be plus 6x. And last is going to be negative, wait a minute. Where did I get that? It's going to be positive. Let me just see if I wrote that right. Yeah, positive 6. Okay. So I just FOILed this, right? And then you subtract that 53 minus 53. All right. So that's the right side. We just found the common denominator by multiplying this one top and bottom by x minus 2. Now, since the denominators are the same, we can just cross them out and set the tops equal to each other. So we're going to get 24x squared plus 25x minus 47 equals, now if I simplify this guy all out, we're going to get negative 8ax squared minus, I'm going to take a 3x out of this. So I'm going to get a minus 6, a minus 2. And then it's going to be minus 47. Okay, what's the question? What's the value of a? I didn't even need to do all that work. I didn't even need this, right? So these are the same. We got 47, 47. Remember these kind where you have to get them to match up? And this one's going to match this. And 24 has to be the same as negative 8a. So if they're going to be equal, right? The x squareds need to be equal, the x's need to be equal, and the numbers need to be equal. So all we do is say 24 has to equal negative 8a, and so a has to equal negative 3. And that is answer B. Wasn't that fun? No comments on the funness of that? Nothing? Okay. Let's go on to the next one. We have 11, 12, 14. You guys missed 14? Oh man. Okay. I won't make fun of you. Okay, 14, quadratic formula. You got to know that. I think most of you do. I mean, jeepers creepers, most of you I had, right? Yeah, all you guys are left. You were in my math class. Okay, quadratic formula. Know this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty, now, first thing you want to do, you want to solve it. You're going to have to use the quadratic formula. See those radicals in there? But you always want to reduce it if possible because it keeps you from making errors and it makes the problem easier. So I'm going to divide everything by 3. Don't forget to do that. X squared plus 4x plus 2 equals 0. And then we just plug it in. Negative 4 plus or minus the square root of b squared minus 4ac all over 2 times a. And you're going to get negative 4 plus or minus the square root of 8 over 2. That is obviously not an answer, but we can simplify negative 4 plus or minus 2 root 2 over 2. And we can take out the 2's. Oh boy, this should have been a 4. I reduced it too soon. And then we reduce it and we're going to get this answer right there. Okay. That's that. All right, let's move on to the next part, which would be number 18 is the next one we have. 18. Oh, this one. Okay, so you guys are good. You got this one? You got number 16, right? Really? No one wants to see that one? Bryn, did you put the problems you missed? Let's see. Yeah, I got them.
You can
Okay.
do 16 if you want.
If I want to, let me see what time it is. 16, one possible solution for that. It's a factoring problem. I actually did it by doing synthetic division. I just got carried away there. So it's x to the 5th minus 5x to the 3rd, distribute it through, and then I'm going to add the 4x over here equals 0. Did I get all that right? And then you can take out an x, and you get x to the 4th minus 5x squared plus 4 equals 0. And then you can factor it such as this, and you get x squared minus the 4 and x minus 1. X squared minus 1. And then you can factor this into x plus 1, x minus 1, or x plus 2, x minus 2. And so your possible answers are you could have 1. They want greater than 0, so it's going to be 1 or 2. And those are the 2 answers. This one's pretty simple. It's just like a simple algebra problem. And then, let's see. I know you guys are probably rusty. That's why you got to really do some more tests. Oh, what's this one about? 18. 2 isosceles triangles are shown if, oh boy. So if 180 minus z equals 2y and y equals 75, what's the value of x? Okay, I don't think those are not vertical angles, so keep that in mind. So you have y equals 75, so 75 right here. So what do we know? I'm not sure where we're going. We want this value right out there. And we know that z, I would just solve it for z maybe. Let's see. So 180, so let's solve this one for z. 180 minus 2y equals z, right? And we know y is 75, so put a 75 in there. So we get 180 minus 2 times 75 equals z, and you know z equals 30. Oh, this is not too bad. So you didn't need to write that there. So z equals 30. This is an isosceles triangle, so you know that this equals this. So I'm going to subtract it from 180, and we get 75. Is that what it is? No. Yeah. Is that 75? 180, help me here, is 150. So this one's 75, and this one's 75. And so this is going to make a straight line. So that one has to be 105. So the answer is x equals 105 degrees. Okay, how's that feeling? Making sense to you? Let's see. Can't read my messages. Okay, so that is all you guys had. You didn't ask for the trig problem. I guess you got that right. Or the lunch stand problem with the hamburgers. Anybody? So even if you can't find, the way you find the answers to these is you can just Google it. You can say answers to test 3, section 3, or the answers are at the end of the chapter, at the end of the test. There's solutions, there's full solutions. So I want to do Rachel's question real quick, and then we will go. So here we go. Whoops, sorry, I hit the wrong button. There we go. All right, so Rachel asked to do one from the last test. Rachel, I'll try my best to explain this. Like, I can't believe the person in your video said it was too complicated and not to do it, or they didn't do it. So let me see if I can find it here. So the one that Rachel had a question with, and then we'll get you guys out of here, is it's test 5, section 3, number 15. Now, when you guys remember, the most accurate tests are tests 10, 9, and 10. In your book, it's set up that way, where test 9 is first, or test 10 is first, one of them. So do test, when you're practicing, 10 and 9 are most like real SATs. So when you're redoing, when you're studying, go back and do those tests first. And then in the beginning of your packet book, it tells you which tests are the best tests. So Rachel's question was, Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer miles he should drive each week? So he wants to save $5. So I feel like no one's here anymore. You guys here? Okay. So we figured out, like, I did this little chart. I was doing all kinds of weird things here for this problem. Wait, I lost my chat and everything. Hold on. Whoops. All right, hold on a second. I'm writing all over the board. Hold on a sec. All right. Oh, I just did all that to say, yeah, I know. It's $5 worth of headache. Seriously. Okay. So first of all, I did this little chart thing. I mean, you guys didn't need to do this. Sometimes I just do dumb things. Did someone leave? Did Bryn leave us? She said, I'm out of here. So if this is 100 miles right here, this is 100 miles. So that means if I break these into 25, because he can do 25 miles in a gallon, there's 25. So this would be 1 gallon, right? And each gallon cost $4. So Alan's spending $16 a week for gas, right? But now he wants to figure out how many miles. So we want to figure out the miles. He wants to save $5. He wants to get down to 11. So we figure out that he is doing, it's basically $4 for 25 miles. For 25 miles. Is it 25 miles? Now I forget what number that is. Yeah, 25 miles. So then you have to take it times the number of miles that will give you the $5. So this is the basic amount, $4 for every 25 miles. And then we have to figure out how many miles would give you $5. So this is actually the answer. Yeah, it's very unsatisfying. $4 for 25 miles, that's what the cost is, and then you have to figure out how many miles. All right, so yeah, that's it, and it's not very exciting. Okay, guys, so I can't wait to hear how you do on your SAT, but you're rusty, you're out of practice, you need to review. You have how many weeks? Like 2 weeks till you get there, till the SAT?
I think I have like 3.5.
3 weeks, okay, so don't slack. So go back and do those tests and practice those things and find your area of weakness and practice those more. So many different types of problems. It's kind of crazy, but I know you guys can do it. So I want to hear some good test results. I want to hear some like perfect scores would be really nice. No one's ever gotten one yet. So be good. I think you guys can do it. So anyway, so I'll see you guys someday, maybe.
Thank you.
You're welcome.
I'll email you my scores. Hopefully they're not bad.
Yeah,
Yeah, send me your scores. I always keep them. I record them.
No.
I do. So I have like spreadsheets for everything. So anyway, we'll see you guys later. Have a good night, week, weeks. All right. We'll see you guys. Bye-bye.
Bye.